it's a kind of a grainy picture, but get it? Sometimes when you're solving a word problem, you arrive at the father's age is 1, and the baby's age is 27. And so then somebody, like face swap the picture of the baby and the dad, and that's what it looks like.
Is it a house that you sell in the map?
Okay.
I'll show you something.
Okay, show me someday.
Okay.
All right. So today we're going to be talking applications of the sequences and the series. But before we start, I would like to do this as a warm-up problem because I think it's a great warm-up problem. And because there's one like this on your homework that's due tomorrow, and because NTC loves these problems, and might put one like this on your final. So I feel that we should at least go over it at some point. You want to tackle it on your own, or do you want to just flat out go through it together? Go through it together? Okay, right. So what does sigma mean? When I see sigma notation here, what does that mean? We talked about it last Friday. What does sigma mean? No, sigma is that funky looking. Oh. But what does it mean? No, that's a sequence. There's a pattern to it. There's a pattern to it. What does it mean? This is kind of important. Kind of the whole crux of the thing. Look back in your notes on Friday. What did we do when we had problems that dealt with sigma? Look back in your notes from Friday. What did we do when we had sigma problems? Yep. No, other way around. Starts at the bottom. Okay. Well, what did we do? Sigma means something. You have no idea what you're talking about. I know, you still haven't watched the video yet, right? You haven't watched the video. Do you think that would have been something you probably should have done in the last 5 days? They were all in class. That's why they're looking in their notes. Yeah. I'm just saying. You know what I mean? You're going to be lost here. Just saying. Sigma means what? Okay. Sigma means what? What's a series? Stop. Go back. Start that again, but go slower for me. Stop. One more time. The what? Sigma means what? My God, we better write this down. Holy cow, should we write this down? Sigma, big letters, put stars by it. Sigma means sum. Okay? Which means we need to find the sum. We only saw sigma on Friday back when we were dealing with sums. Sigma. Oops, I forgot to end. Okay? So, still on Friday's notes. Still haven't watched the video yet. Still there. Okay? What do I need? What 3 things do we need to find the sum of a series? We need 3 things. We need the first term. We need the last term. and we need the total number of terms. Right? Okay? How do I find the first term? Still on Friday. Haven't even gotten to this problem yet. Still on Friday. How do I find the first term? Into the rule. So I'm going to plug the bottom number into my rule. So that's going to be 5 minus 5 times 1. 5 times 1 is 5. 5 minus 5 is 0. So my first term is 0. Okay? How do I find my last term? Still on Friday's notes, how do I find my last term? To find the first term, we took the bottom number, we plugged it into our rule. How do I find my last term? Take the top number and we plug it into our rule. So that's going to be 5 minus 5 times n. Do I know what n is? No, that's the whole point of this problem, right? So that's just going to be 5 minus 5n. From Friday, how do I find the total number of terms? Nope. Should be written. If you took good notes on Friday, we told you how to find the total number of terms based off of a sigma. Top number minus bottom number, so that would be top number is n minus the bottom number is 1 plus 1. How many total terms do we have in this one? N total terms. Still don't know what n is, right? Okay. So now we found the 3 things that we need for the sum. What is the sum formula that we now have to use? That is to find any term. That is not the formula to find the sum. S sub n is equal to first term plus last term times n over 2, right? Okay. So my formula is S sub n equals n over 2 times first term plus last term. Okay. My question to you now is, so this is my total number of terms, right? Which is how much? How many total terms does this sequence series have? We literally just found it. What do you got, Ray? It's got n total terms. It's right there. It's one of the 3 things that we had to find. It's n. That's going to be over 2. What is the first term in this series? 0. What is the last term in this series? What is it? 5 minus 5n. I don't know where you're getting that from. Okay? So that's the 3 things that we had to find, right? Now, if sigma means sum, what is the sum of this series? If sigma means sum, based off of this problem, what is the sum of this series? Say it loud. -50. Because sigma means sum, that means that the sum of this series is negative 50. How are we going to go about solving? You tell me. This now becomes an algebra problem. Good thing you are all in Algebra 3 here at Russell West, which is also college algebra. You tell me how we can solve this algebraic problem. Love it. We can make the parentheses look nice and pretty. So we could make this be negative 50 equals n minus 2 times 5 minus 5n. Love it. Great, great first step. What do we do next? I would say that you can't go wrong, but there are many things that could go wrong here. So, but there are really, from my perspective, I see two different ways of doing it. Multiply by 2? Yeah. Love it. Multiply by 2 because that gets rid of the fraction, right? Yeah. Okay. So if I multiply here by 2, then I got to multiply there by 2. Everybody agree with that? Okay. Because I've done both on the same side. Let me extend my page right there. That would give me negative 100 equals n times 5 minus 5n. I love this path that we were going down. It's much easier than the other path. Now what's next? Distribute. It starts with a D, ends with distribute. We got to distribute that n. If I distribute this n, I get negative 100 equals 5n minus 5n squared. Oh, snap. What do you mean? I multiplied the whole side by it, yeah. But I just multiplied it in right there. Because it's outside the parentheses. I could multiply, like if that n over 2 was inside the parentheses, I couldn't do what we just did. But because it's outside, it's got better rules. Okay? Now what? Still on an algebra problem. Which way do you want everything to go? To the right or to the left? To the left, because then that gets a positive on our squared term. Love it. So then this would become 5n squared minus 5n minus 100 equals 0. Again, two paths could diverge in the woods. We wanted to here. Would be a path diverging off the path that already diverged. What could we do next if we so choose? Factor what out? We can divide everything by 5, right? Okay? So now I can divide here by 5. I can divide here by 5. I can divide here by 5. And I can divide here by 5. That makes my numbers be a little bit smaller. N squared minus n minus 20 equals 0. Love it. Now what do we have to do? What kind of a factoring are we going to go with? Butt cheeks? Talk to me. And what? Minus 5 and plus 4? Okay. Now what? Great problem. Why do NTC loves these problems? Because it's a great problem. How? That each of them equals 0? What do we get? And it's 5, 4, and it's negative 4. Right? Now what do we got? Right? Let's go back up here and check, right? We got to scroll all the way back to the top. Okay? Could I have 5 terms in this series? Makes sense, right? I could have 5 terms in this series. Okay? So n equals 5, still a possibility. Okay? Could I have negative 4 terms in this series? Why not? Because it's negative. Can't have a negative term number, right? We're only doing n starts at 1. We learned that on Thursday. N starts at 1 and it just goes up, right? Okay? So negative 4. Kick that one out, right? Yep. So my only leftover answer is n is 5. Now, we can go back up here, and we can go right back up here to our, here we go. So if n is 5, let's check it here in the black. So if n is 5 over 2 times 0 plus 5 minus 5 times 5. Okay. Okay. So this is going to be 5 minus 25 is going to be negative 20, right? So negative 20 is going to be times 5 halves. Well, that's going to be 5 times negative 10, which is going to be negative 50, which is what our sum was. So it checks out n is 5. Okay. Again, NTC loves those problems. Don't just skip over a number. I want to say. Skip number 10. Okay. So here is our first application type problem. A field house has a section where the seating can be arranged so the first row has 4 seats, the second row has 6 seats, the third row has 8 seats, and so on and so on. If there is sufficient space for 30 rows in this section of bleachers, okay? Obviously this is a corner section because it's getting wider and wider and wider every time. Okay? Okay? So in this corner section, how many seats are in the last row of that section? Okay? So what sequence do we have here? What is our sequence, the start of our sequence? 4, then 6, then 8, then so on and so forth, right? What would the next one be? 10, what would the next one be? 12, next one, 14, and so on and so forth, right? Now, we could do that 30 times if we want. Okay? But we don't have to, because BFG gave us a formula earlier. Do you remember what that formula was, BFG? What was it? A sub n, not A of n. A of n is a function. This is A sub n, which is a term number, just so you know. Okay? So that formula was Thursday's formula, right? Okay? Thursday's formula told us that we can use that formula to find any term in the sequence. Right? Okay? So if we can find any term, that means that we need to find which term. We're looking for the 30th term because we got 30 rows in our section, so we need to find A sub 30. Okay? So A sub 30 is going to equal what is the first term in this sequence? 4 plus what is the common difference in this sequence? Positive 2, because we're always going up by 2. Love it. Times n. What's n if I'm looking for the 30th term? 30 minus 1. Okay. 30 minus 1 is 29. 29 times 2 is 58. 4 plus 58 is 62 we said? So the 30th row has 62 seats in it, right? Now, notice how I wrote my answer. I didn't just give 62 as my answer, right? Word problems always have labels, which means your answers need to have some meaning behind it. No naked numbers. Okay? Okay? Then this question went on to say, how many total seats are in this section? Once again, I asked the question, what is the formula for the total or the sum of a sequence? S sub n equals, yep. Okay, so I need to know what the first term is in this sequence or in this series. What was the first row? How many seats way down there in the first row? 4. How many seats in the last row? How many total rows are there? 30 divided by 2 is 4 plus 62 is 66 times 15 is how much? 990? Well, it sounded like you said like 190.
No,
Oh, okay. Yeah, like I didn't hear the 9 part of it. I'm like 190. Whoa, like the first 2 rows or first last 3 rows, there's 190 seats. Okay? So there are 990 seats in this section. That's a lot. This is more of a seat. Or even on college campuses. Okay. Good. All right. Go for it. All right, so my sequence starts out at, so the first day of the month, we got 13. Then the next day, day 2, we got it, we improved up to 16. Then we improved to 19. Then we improved to 22, and so on and so forth, okay? We are asking for on the 22nd day of the month. So that means we're going to have to use this A sub n is equal to A sub 1 plus D times the quantity and minus 1. Where my first term, my 22nd term is going to be equal to my first term, which just so happened to be 13, plus how much are we going up by every day? 3. So we're improving by 3. We're increasing with efficiencies, and then we need to get to the 22nd day here. 22 minus 1 is 21. 21 times 3 is 63. 13 plus 63 is 76. So on the 22nd day, we produce, it just says items. Then it said project the total number of items produced for the month of February. Okay, well, that's going to be a sum. Total is sum. So that is going to be S sub n equals n over 2 times A sub 1 plus A sub n. There. So I need the first term. What was the first term again? 13. I need the last term, which is actually going to be the 29th term, which means I've got to go A sub 1, which was 13, plus 3 times 29 minus 1. I got to use that rule to find that one. 29 minus 1 is 28. 28 times 3 is 84. Yep. 84 plus 13 is 97. Yes? They're looking at me funny. Did I do it wrong? Well, because we have to find how many items we produced on the last day, right? Which is the 29th day. We only found the 22nd day in the problem beforehand. Yeah. Remember, we just had that conversation about how many days were in February of 2024? It's not 22. Okay. So then there are 29 days in February. Okay. So my sum of 29 days is going to be 29 divided by 2 times my first term is 13, my last term is 97. $110. I don't even want to know what's going on over this. I get 1,595. So in February of 24, this factory produced 1,595 items. Yes? CFG, what's the problem? Where's the confusion? What did you figure out? Oh, you were doing 22nd day. See how it says right up here that that was only the 22nd day?
Yeah.
We need the 29th day. Just so happens that there isn't a month with only, actually, I shouldn't say that. That would be a lie. You know how many months have 28 days? All of them. Okay. So that is all I got for you today. I'm giving you 10 minutes here to